Motors Spring Hill facility, and we're out here at the beautiful Duck River. We're here to talk about watersheds and how we can make sure that our watershed is healthy. As I said, we all work at the General Motors facility, but we work for some different companies. We've got people here that actually work for GM. We also have people here who manage our chemicals on site, and folks here who manage our waste. It takes a lot of people working together in order to make sure that we build our vehicles safely and environmentally responsibly. So we need to be responsible with what we do on the land, because that's going to affect the health of our water. And so today we're going to be gathering some water samples from the Duck River. Where you go to school, you actually are living in the Duck River watershed. And so we'll collect some samples, we'll do some chemistry experiments. We're going to look at turbidity and we're going to look at pH, and that's going to give us some indications of how healthy the Duck River is.
So one of the ways we determine the health of the river is by measuring turbidity. So first we'd like to talk about what turbidity is. So turbidity is the measure of the degree to which water loses its transparency due to the presence of suspended particulates. So that's kind of the technical definition, but in more simple terms, it measures the cloudiness or the clarity of the water. So high turbidity is cloudy water, and low turbidity would be the clear water. So causes of turbidity would be suspended organic matter or minerals, and erosion plays a part in how cloudy or how turbid the water is.
So there are some things that can influence turbidity. Erosion is one of the things that can increase turbidity, and what erosion is the amount of sediment or soil particles in the water. This increased sediment influences turbidity. It is very important that our water doesn't appear too murky or cloudy, and this is what is turbid water. All natural waters are somewhat turbid, even if only at microscopic levels.
So you might wonder, how does turbidity affect the wildlife and the animals, all the animals that live in the river? And that's a very good question. And all the fish and all the animals can live in the clear water, and clear water is good because clear water allows the sun to penetrate through the water and allows for some algae and microorganisms to grow, and then those form the bottom of your food chain. And so also those algae and the plant life that's in your river helps generate oxygen. And so fish, of course, they get their oxygen through the water, just like we get our oxygen through the air. They get their oxygen through the water, through their gills. And so the more oxygen in the water, the better off they are, happier they are. And if we have turbid water, the particles in the water tend to transmit that sun, that heat, and they block out the sun from the algae, but they also increase the temperature. And when you increase the temperature, you don't have as much oxygen left for the fish to breathe, and it makes it difficult for them to see their food. So certain species, like let's say for example the catfish, has these barbels on its face, and the barbels, the whiskers that we talk about, those actually are to help them feel around and also to help them smell their food. So in murky water, high turbidity water, the catfish can live great. But the other species like trout and bass, mostly they're using their eyeballs to help find their food and look for insects and little crawfish and minnows and things. So when the water is very turbid, they can't see that. So and the water gets so hot that they can't run around and find their food because there's not enough oxygen. So some of those species cannot live well in muddy water. Now in clear water, everybody's happy because we have photosynthesis, we have plant growth, we have algae, we have microorganisms growing, and the minnows and all the fish have plenty of food to choose from in their whole food chain. But once we get muddy water, we start to lose some of the pieces of that food chain, and it makes it more difficult for the fish to survive.
Okay, we've talked a little bit about turbidity, and now we're going to do a little experiment to determine what the turbidity of our water sample is. So there are 4 steps involved, and step number 1 is to fill the turbidity tube to the line. Then step 2 is to place the base of the tube on the outline of the turbidity chart. So you put the tube, center it on the circle in the middle. And then step 3 is to look down through the sample water at the disc icon under the tube. And then what you're going to do is compare the appearance of the disc under the tube to the gray discs on either side of the tube to determine the turbidity. So it's not an exact measurement. You just use your judgment to determine which circle matches the best.
So when we think about the health of a river or creek, it's important that we understand how we contribute to that. And so the health of a water body is affected by what surrounds it. And that's what we call a watershed. And so a watershed is an area of land where all of the surface water and groundwater runs downhill into a common water body, whether that's a creek or a river or a stream or a lake. And so we're responsible, or we should be responsible with what we do on the land, because that's going to ultimately impact the health of our watershed and the water that we drink and play in. You live in the Duck River, you go to school in the Duck River, or in the Duck River watershed. And so the experiments that we're going to do with pH is going to give us another indication of how healthy the water is in the area that you go to school.
So a lot of you might be wondering, what is pH? What does that mean? pH stands for potential of hydrogen, and it's the measure of hydrogen ion concentration in the water. Pure water is at 7 on a scale of 0 to 14. So when we go into the Duck River and test it for its pH, it should be between 6 and 8. Aquatic wildlife prefer for the water to be a pH between 6 and 8, but some, like frogs, can live in a pH of 4, and some can live in higher pH, like clownfish. We can live up to 8, a pH of 8.
All right, the pH scale goes from 0 all the way to 14. The end of the scale between 0 and 7 is the acidic end of the pH scale, and from 7 to 14 is the alkaline portion of the pH scale. So you have like stomach acid, which is a pH of a 2, or you have a tomato, which is a pH of a 4, and then pure water is a pH of 7, it's neutral. And then you have things like hand soap, which is more on the alkaline end, which is a pH of 10, or even household bleach, which is even higher of a pH of 12. So when we're talking about the health of our rivers, we want to make sure that we're not adding anything into the watershed, such as chemicals or pollution or anything like that, that could affect the pH of the watershed, because then that can make the watershed unhealthy for the aquatic life.
So the way we're going to measure the pH of the water in the Duck River is by using a pH tablet. We're going to first take our water sample and pour it to the 10 milliliter line in the test tube. We're going to add 1 pH tablet and put the lid on tightly to the tube. Shake the tube until the tablet is completely dissolved and the water should change color. You're going to compare the color of the water to the color of the sample on the pH color chart. It should be between 6 and 8. The color should be between a yellow to like a light greenish color.
Some of the things that can influence turbidity. See? Turbidity? Yeah, so some of the things that can influence turbidity. I can't even say turbidity.